scientists made a daring announcement. They assert that they have discovered a new planet unlike anything previously known. NASA is known for its groundbreaking results, and this discovery is no exception. It has shown that not only is this planet fascinating because of how big it is and where it is, but additionally because it projects light that seems to be composed of unknown elements. Are we close to disclosing information that could improve our comprehension of the universe? This finding may indicate the existence of extraterrestrial life. By exploring the amazing discoveries made by NASA, we may soon discover the truth about these extraordinary illuminations. In 2007, with the launch of the Dawn spacecraft, a mission to investigate some of the most intriguing objects in our solar system, NASA took a bold step. Dawn had 3 ion engines and was capable of beginning a journey that started with a 14-month investigation into Vesta. Vesta is the second-largest asteroid in the belt. Dawn sent back comprehensive data and images, exposing the intricate surface of Vesta and a wide range of geological history. After achieving its goal at Vesta, Dawn started the second and possibly most enthralling phase of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and move in a direction not possible with conventional chemical propulsion. These engines offered a gentle thrust that enabled Dawn to travel a considerable distance and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Jupiter and Mars. For a long time, it was regarded as the smallest dwarf planet in the solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most fascinating body in the asteroid belt due to its unique traits. Scientists eagerly awaited the first complete images of this enigmatic world. What they saw were bright spots dispersed across its surface, particularly in a large crater known as a crater. These shining areas immediately sparked interest and speculation in the scientific community. Before dawn, the best image we had of Ceres was a low-resolution, blurry photograph taken by the Hubble Space Telescope. There was little information about this tiny planet, and the possibility of finally receiving high-resolution data promised great discoveries. The Dawn mission sought to enhance our understanding of water's role in the solar system and the process by which planets are formed. The bright spots on Ceres, also seen on other asteroids, might be made of potentially reflective material, salts that remain after water has sublimated. This raised the possibility of cryovolcanism, a process in which volcanic eruptions produce liquid water or brine instead of molten rock. But what exactly are these enigmatic lights? What clues do they provide about the nature of Ceres? They might be evidence of ongoing geological activity. Ceres stands out from other bodies in the asteroid belt due to its size, mass, composition, and the possibility of containing water and ice. Unlike the typically rocky asteroids, Ceres features a comet-like composition, implying it might reveal additional information about the early solar system. After traveling for 2 years, the Dawn spacecraft finally approached Ceres in early 2015. This marked a significant turning point as it prepared to deliver the first close-up shots of the largest object in the asteroid belt. As Dawn got closer, images of Ceres became more detailed, revealing a previously hidden world. The initial images showed a cratered surface, indicating a long history of impacts. What caught the attention of researchers and space enthusiasts were the mysteriously bright spots on the dark, rocky terrain. As the image's resolution improved, the scientific community developed theories about the nature of these shining areas. Were they ice patches reflecting sunlight, or something else entirely? More exotic theories suggested mineral deposits or even indicators of active geological processes. To everyone's surprise, a closer look revealed that there was not a single bright spot, but a collection of distinct ones. The most widely accepted hypothesis is that these are deposits of salt created when subsurface water sublimated. This suggests that Ceres either had or still has geological activity capable of bringing such material to the surface. This possibility of geological activity, especially cryovolcanism, on Ceres challenged long-standing assumptions about small bodies in the solar system. Until now, most scientists believe that only larger planets or moons, such as Europa or Enceladus, could harbor subsurface oceans or exhibit signs of internal heat. Ceres, however, offered a compelling counterexample. Despite its relatively small size, the evidence suggested it had retained enough heat and volatiles to drive activity beneath its crust. Dawn's instruments detected compounds like ammonia-bearing clays and hydrated minerals, pointing to the presence of ancient water. Even more intriguing was the detection of localized water vapor emissions. While these were not constant, their presence hinted at dynamic processes still taking place on or beneath Ceres' surface. Could this small dwarf planet host temporary reservoirs of brine, pressurized beneath layers of ice and rock, occasionally venting through surface fractures? The Achater crater became a prime focus of study. The central bright region, later named Cerealia Facula, was found to be rich in sodium carbonate, a type of salt that forms in water. This composition strongly suggested that the material had been transported to the surface by liquid water, which then evaporated and left behind the gleaming deposits. This process might have happened relatively recently in geological terms, perhaps within the last few million years, a blink in the cosmic timeline. Moreover, gravity measurements from Dawn hinted at a partially differentiated interior, another sign of past internal heating. Combined with topographic and spectral data, these findings help scientists build a more complete picture of Ceres as a world shaped not only by external impacts but also by internal evolution. All of this painted Ceres not as a static rock in space, but as a world with a complex past, and perhaps an active present. The implications extended beyond the asteroid belt. If a small, icy dwarf planet like Ceres could preserve and occasionally release liquid water, then similar bodies throughout the solar system, and even beyond, might be more habitable than previously imagined. In the end, the Dawn mission redefined our understanding of planetary science. It demonstrated the incredible value of ion propulsion, enabling one spacecraft to orbit two distinct celestial bodies. More importantly, it revealed the extraordinary complexity hidden within what once seemed like a simple asteroid. Ceres, with its mysterious lights, icy crust, and hidden brines, became a symbol of how much remains unknown in our solar system. It stands as a reminder that even in the dark, cold reaches of space, there can be glimmers of activity, of possibility, and perhaps, one day, even of life. Brine or water reaches areas on the surface where they rapidly evaporate, leaving behind brightly reflective traces. These findings challenged previously held beliefs about Ceres and created a picture of a more complex and dynamic world than previously imagined. The possibility of the existence of brine or groundwater pockets may have significant effects on our understanding of the potential for life in our solar system. Ceres is a fascinating dwarf planet, frequently described as a world of ice and rocky terrain, but it has a porous surface, distinct from most other surfaces that primarily consist of rock and metal. Ceres stands out for its unique composition, a surface combination of hydrated ice and water-rich minerals like carbonates and clays, which give it a structure that is less dense than its mountainous neighbors. This composition suggests that a substantial amount of water exists on its surface. The outer layer is rocky but contains ice and is porous, with other volatiles trapped inside, making it more like a comet than an ordinary asteroid. This dwarf planet is thought to have a distinctive interior, with a muddy, ice-rich mantle and a core high in water, which may represent approximately 50% of Ceres' volume. The mantle is likely a mixture of brine and rock, surrounded by a possible core made of higher-density materials like silicates. The presence of a substantial amount of ice and water suggests that Ceres may have formerly held liquid water, especially if its core was heated by the early decay of radioactive material. This internal structure sets Ceres apart from the nearby asteroids and raises intriguing questions about its geological activity and the role of water in its development. However, that isn't all. The discovery of ammonia-rich clays suggests that this dwarf planet may have formed in a cooler region of the solar system and later migrated inward. The presence of ammonia may lower water's freezing point, supporting the existence of surface brines. These insights into Ceres' history and composition not only expand our understanding of this remarkable dwarf planet, but also shed light on the processes that govern the formation and development of icy bodies throughout the solar system. Cryovolcanism is a fascinating and extremely rare geological process, particularly when compared to more familiar volcanic activity on Earth. Unlike conventional molten rock volcanoes, cryovolcanoes, ice volcanoes, expel substances like water, ammonia, or methane, materials that can exist as gases or liquids in extremely cold environments. Ceres cryovolcanoes function by allowing salt-laden water to rise until it reaches the surface. Once the salt water contacts the vacuum of space, it rapidly transitions, often sublimating directly from solid or liquid into gas, leaving behind glowing, reflective salt deposits. These salt residues form the enigmatic bright spots found on the surface of Ceres. The most well-known of these is located in Achater crater, also known as 5. This region has attracted considerable attention due to high reflectivity and the periodic haze observed by NASA's Dawn spacecraft. These hazes are thought to result from water sublimation, suggesting that activity may still be ongoing, or may have occurred relatively recently. In addition to Achater crater, numerous other bright regions, each with unique features, have been identified across Ceres' surface. These locations are not restricted to a single area but are scattered across the planet-sized dwarf, indicating that cryovolcanism may be a widespread phenomenon on Ceres. These glowing areas emphasize Ceres' active and dynamic nature, overturning previous assumptions that it was geologically inactive. As the Dawn spacecraft provided more images, numerous surface features began to appear on Ceres. Each crater tells a story about the history of the dwarf planet. As Dawn moved into orbit around Ceres, scientists gained a deeper understanding of the planet's internal and surface processes. One of the most exciting revelations was the discovery of organic molecules, the building blocks of life. In 2017, NASA announced the detection of aliphatic organic substances near one of Ceres' craters. These carbon-based molecules are commonly linked to biological processes, though they can also arise through abiotic mechanisms. The presence of both brine and organics, alongside evidence of past or present liquid water, suggests that Ceres may have once had, or still maintains, conditions that could support microbial life. However, no life has been discovered to date. The convergence of organics, internal heat, and water chemistry makes Ceres an attractive target for astrobiological research. From a cultural and historical perspective, Ceres also holds a special place in the history of astronomy. It was the first object discovered in the asteroid belt and was originally classified as a planet. It was later reclassified as an asteroid, and eventually as a dwarf planet. Its evolving status reflects the development of celestial classification systems and our expanding understanding of the solar system. Scientifically, Ceres is a time capsule from the early solar system. Unlike larger planets that have undergone intense geological processing, Ceres has remained relatively unchanged. Studying it offers valuable insights into conditions that existed 4.5 billion years ago, helping scientists develop theories about planetary formation, migration, and differentiation. Let us know what you think in the comments section below. If you enjoyed this content, be sure to like the video and subscribe. As scientists continue to study Ceres, one of the most compelling avenues of research is its potential for harboring subsurface oceans or isolated pockets of liquid water. Such environments, even if short-lived or episodic, open up possibilities for habitability in places far beyond the traditional habitable zone of our solar system. Unlike Earth, where life depends heavily on sunlight, the subsurface of Ceres might rely on internal heating and chemical energy, much like the ecosystems found around hydrothermal vents in Earth's oceans. Future missions to Ceres may involve landers or even subsurface probes capable of penetrating the crust to explore the briny reservoirs suspected to lie beneath. These missions could help answer profound questions. Did microbial life ever arise on Ceres? Could it still exist? What do the isotopic ratios in Ceres' water and organics reveal about the early solar system? Moreover, Ceres presents a testbed for in situ resource utilization, ISRU. The presence of water, ice, salts, and minerals makes it a potential site for future human missions or robotic mining operations. Extracting water for fuel or life support could support longer-term missions in the asteroid belt or serve as a stepping stone for exploration deeper into the solar system. On a broader level, studying Ceres contributes to comparative planetology, the science of comparing planetary bodies to better understand the formation and evolution of all planets, including Earth. Each discovery on Ceres reverberates across multiple disciplines: planetary geology, chemistry, astrobiology, and even the study of climate and atmospheric processes on other worlds. In conclusion, Ceres is far more than a rocky remnant or a large asteroid. It is a dynamic, water-rich world that challenges our assumptions about where life can exist and how planets form. Its bright spots, cryovolcanoes, and organic compounds are more than just geological curiosities. They are clues to the grander narrative of our solar system's history and perhaps even to the conditions that gave rise to life itself. Stay tuned as exploration continues, because the story of Ceres is only beginning to unfold.